welcome Thierry, Thomas, Dangin, who is researchers in INRA Dijon CHGA, and we continue about the formulation.
Thank you, Camille. Good morning, everybody. First of all, I would like to thank the organizing committee and scientific committee for inviting me to this symposium in order to tell you about taking advantage of aromas to optimize liking in low-salt foods. So, as an introduction, let me show you this picture. It seems that this lady disliked the food she's eating. It could be because it's low-salt food. Indeed, as Marcus already told, in low-salt food, it is good for health. However, it could be also bad for taste. In both cases, it's a major issue. Why? Because if you design low-salt food and people dislike it, they will not eat it. Or they will probably add salt before they eat it. In both cases, it's not a good thing because the design of this low-salt food is useless if people cannot eat or add salt in it. So there are, at the moment, several research who try to investigate the many solutions that can help to decrease salt in foods while maintaining the taste. Most of them imply a deep change in the matrix structure and/or its composition in order to increase the quantity of salt released in the mouth, or modify the sodium release kinetic, or add compounds which are not present in the original product. One of the strategies we try to investigate in our laboratory is the strategy based on salt-free aromas that could be used to compensate for taste decrease in low-salt food. In order to understand why aroma can compensate for loss of salty taste, we have to go back to a scientific context and understand what happens when we eat food. When we eat food, for example, strawberry in that case, the food is put into the mouth, and then the food is destroyed into the mouth, and some chemical compounds are released. Some of these compounds, for example, fructose, this sugar, can be dissolved in saliva and reach receptors which are located at the surface of the tongue. Other compounds, volatile compounds, such as this ester, can be put into the volatile phase of air, which is coming from the outside of the body, and reach the receptor, which are located into the upper part of the nose, where are located the olfactory receptors. In both cases, soluble compounds or volatile compounds reach receptors. These receptors can give information to the brain so that this information come into the brain in several parts of the brain. For the compounds which are soluble in the saliva, they reach the gustatory cortex, and the compounds which are volatile reach the olfactory cortex. But what is interesting is at the moment, both information can merge into one part of the brain, which is located more or less here, and which is called the orbitofrontal cortex. And in this cortex, you have a merging of both information coming from the tongue and from the nose. In the end, the brain interprets the pattern which is sent by the receptor, and you can recognize the food, for example, the strawberry. So the merge of taste and odors can give rise to the flavor, which is called the flavor, and the food flavor can be considered as a sensory percept, relying on the functional integration of information transmitted by the chemical senses, that is to say olfaction, gustation, but also oral and nasal somatosensory inputs. During food flavor brain integration, there are multi-sensory integration that can occur, And for example, one of these integrations concerns the binding of smell and taste. This interaction between smell and taste gives rise to the possibilities that odors can evoke tastes. So to illustrate this, let me first begin with a quiz in which I propose that you participate. If you follow my instruction, I propose you to close your eyes, then imagine you are at the moment smelling an odor. To do so, you can make a sniff. Then you can imagine that the odor you are smelling is a lychee odor. Once smelling this lychee odor, could you tell me if this odor tastes sweet? Those of you who think that this odor tastes sweet, please raise your hand up. Okay, most of you think this odor of lychee tastes sweet. If you do the same thing and you imagine that this odor tastes salty, please, those who think that this odor is salty, raise your hand up. Nobody raised the hand up. This is to show you that when you expected to smell something, you imagine you smell something, you can also imagine that you have a taste in your mouth. Starting from this observation, we made a sensory experiment in our lab in which we asked people to imagine the odor of food names, relying on food names. So we proposed 86 food names, and we asked to 81 consumers to make an expectation profiles as far as taste dimension are concerned. So we asked them to say if, for example, lychee odor is bitter, sour, salty, and sweet. The data we obtained were submitted to a multivariate analysis, in that case, a principal component analysis, and the results are shown on this graph. So there is several information on that graph. I hope you can see nothing, but what is important in that graph is that you have the 4 dimensions we recorded, that is to say bitterness, sweetness, sourness, and saltiness, and you can see that these dimensions are more or less well separated in this graph. And what you can see is that some aromas, like anchovy, sardine, or bacon, or peanuts, or chicken, are very well related to the saltiness dimension. This is only expectation in that case. On the contrary, tomato odor or carrot odor are much more related to sweetness or sourness. So if there is a very strong link between the odor and the taste, which is expected, it is likely that odor can also modify taste and probably, in some case, enhance taste, which is very interesting in the case of salty dimension and salt decrease. To evaluate this effect, we perform a sensory analysis using water solution in which we put aroma and in which we put salt or not. We performed this analysis in our laboratory with 30 consumers, and we asked them to rate the taste dimension of the solution, but also the odor intensity. So here are the results. On this graph, you have on the y-axis the saltiness intensity, and on the x-axis the aroma solution, which are aroma solution salt-free. There is no salt added into this solution. And as you can see, there is a high difference between the solution concerning the salty dimension. Of course, water only is very poorly salty, but when you increase carrot, tomato, and then you have anchovy, bacon, and sardine, you can see that this salt-associated aroma gives the impression to the consumer that there is salt into the solution. And interestingly, there is a high correlation between the perceived induced salty taste by this aroma with the expectation scores as far as salty dimension is concerned. Then I present you the result of the solution in which salt was added. To do so, I refer to one dimension which is called the odor-induced saltiness enhancement, called OISE. This OISE is calculated on the basis of the saltiness or salt intensity for a solution which contains salt and aroma, and a solution which contains only salt, so aroma-free solution but containing salt. So the RAC in this graph is represented on the y-axis, and you have the aroma we use. And as you can see, once again, there is a difference between the aroma concerning the possibility to enhance the salty intensity into the solution. And you find the bacon, sardine, anchovy, peanuts, ham, which are the aromas that have the ability to enhance the most the salty dimension. On the contrary, the tomato and carrot aroma we talked about in the last minutes are not able to enhance this saltiness. This proves that selected aromas which are associated to salt, can enhance saltiness. On the contrary, aromas that are not associated to the salty dimension have not this ability. So this is a demonstration in, let's say, simple water solution, but does it work in real food model system? To do so, we use cheese-like products, that is cheese we built into the laboratory, in which we are able to manipulate several parameters. In the cheese we elaborate, we modify the dry matter content, which is the first figure here, and the fat content, which is the figure here. So you have cheese, let's say low-fat cheese and high-fat cheese. And in this cheese, we put some aromas, Comté cheese aromas, sardine aromas, and carrot aromas. A total of 12 flavored and 4 unflavored molded cheese were tasted by the consumer. And we asked them to rate the taste dimension and also the odor intensity. The results are reported here with the OISC. And as you can see, for the first type of cheese, so high dry matter and low fat, you can see that the carrot aroma has not the ability to enhance the saltiness, while Comté cheese and sardine aroma have a low ability to increase the saltiness. But interestingly, when you look at the other composition of the cheese, even if carrot is never able to enhance saltiness, depending on the composition of the cheese, dry matter content, fat content, the ability of the aroma to enhance the saltiness is changing, probably due to texture effect or aroma or salt release effect. So salt-associated aromas can enhance the saltiness in solid foods, and the composition and or the texture influence this enhancement. We also had a look at the limits of this odor-induced saltiness enhancement. One of the limits I want to show you today is the limit that is linked to the salt concentration. To show this limit, we use the water aroma solution with different concentration of salt. And we ask our consumer to rate the saltiness of this solution. And you can see the results on that graph, where you have the saltiness enhancement on the y-axis, and you have 3 solutions with increasing concentration of salt in it. So what you can see clearly is when you increase the concentration of the salt into the solution, you decrease the enhancement effect. So there is an odor-induced saltiness enhancement in this solution, but it decreases with the increasing the saltiness concentration, probably the saltiness intensity. The odor-induced saltiness enhancement, as you can see, is able to operate in a model water system, but also in a model food system. But what is interesting is that can it be combined with other strategies that are currently developed to compensate for salt reduction. One example I want to show you is the use of a salt replacer, which is potassium chloride. We also use water aroma solution in which we put either sodium chloride or potassium chloride. And we ask our consumer to rate the saltiness intensity, which is reported on the y-axis here. And as you can see, the water only is not able to evoke saltiness. Potassium chloride can evoke saltiness. Sodium chloride, of course, evokes saltiness. And we have a reference in this study, which is a solution with sodium chloride, but with an increase of concentration of 25%. When we add aroma to this solution, you have the result here. You can see that the aroma, in that case, it's the sardine aroma. It can increase the saltiness sensation in the sodium chloride, which is the same thing as I showed you before, but interestingly, it also works with the potassium chloride and even more with the potassium chloride as compared to the sodium chloride. And if you put aromas into sodium chloride solution, you can compensate at least for a reduction of 25%, and probably more, of course, if you use potassium chloride or if you use a combination of sodium and potassium chloride. This is in a water solution. What does it happen when you use this combination of strategies in real food system? To do so, we use the strategies of odor-induced saltiness enhancement and the strategies which has been shown you by Marcus before, which is the strategy of heterogeneous distribution of salt into the product. To do so, we use a real-like food product that we designed here in our laboratory, which is a product composed of 4 cream-based layers. This is what it looks like. In fact, you cannot see very much, but there are 4 layers in this product, and we can manipulate the composition of these 4 layers. There is on whole the product we use an overall salt concentration which is identical from a product to another, and we use sodium chloride and ham aroma into this product, and we make it varies depending on the layers. That is to say, we have 3 layers of heterogeneity for salt distribution and aroma distribution in this product. So this is a schematic representation of the product we use. First, we have an homogeneous product in which salt and aroma are homogeneously distributed into the product. So the color refers to the distribution of salt, and the star refers to the distribution of aroma. We have another kind of product in which salt is homogeneously distributed, but aroma is not homogeneously distributed. It can be either in the top layer or in the middle layer. Then you have the heterogeneous distribution of salt. Salt can be in the upper layer or in the middle layer, and you have several other combinations we test depending on the distribution of the salt or the aroma. We have also a control reference in this study in which we have an homogeneous distribution of salt, but at a concentration 35% higher and without aroma. We perform sensory analysis with more than 100 consumers, rating the saltiness intensity of this product, and the results are shown on this graph. So you have the saltiness enhancement for each product represented on the y-axis. First, I show you the product in which there is only salt, but at a higher concentration. Of course, there is an enhancement of saltiness because there is much salt into this product. This is a reference. Then you have all the products I presented to you. First of all are the products in which you have an homogeneous distribution of salt, but an heterogeneous distribution of aroma. As you can see, aroma is able to enhance saltiness, since the saltiness enhancement is higher than 0, and it is significant, at least for some products. In the product where we mixed the distribution of salt and aroma, you have also an increase of saltiness perception. This increase is even higher when you have the salt, which is only located into one layer of the product, whatever the distribution of the aroma. And you have also the same effect in which you have the salt distribution, but in the outside layer of the product. It seems that putting salt into the outside layer of the product is even more efficient. And the product with the highest saltiness is the product in which you have an heterogeneous distribution of salt and an heterogeneous distribution of aroma into the outside layer opposite. With this product, you can compensate for a reduction of salt of more than 35%. So, to conclude this presentation, some take-home messages. Aromas are associated to taste due to flavor processing. The salt-associated aromas can enhance salt taste perception. This is the odor-induced saltiness enhancement. The salt-associated aromas can be used to compensate for salt content reduction in food, even in real food. The food composition and/or texture influence the odor-induced saltiness enhancement, probably through release or mechanisms or perceptual interactions mechanisms. The odor-induced saltiness enhancement can be combined with other strategies to compensate for salt reduction through taste-taste interactions, stimuli contrast, or change in composition. And all these aspects are still investigated into the EU Terrific project that you can have a look at the website of this project. And I also recommend you to have a look at our poster, which is a poster of one of our students, Adian Siasari-Fudin, poster number 29, I think, which is related to counterbalancing salt reduction with aroma and consequences on sensory acceptability, a study with real cheese. I finish by thanking all the contributors to the results I presented to you and our partner who support this research. And I thank you for your attention.
Thank you, Thierry. Again, do we have a question in the... Yes, Sophie.
Thank you very much for this very interesting presentation. What kind of aroma have been used for this study? Was it natural aroma or artificial aroma?
This is commercial aroma. I don't know if they are artificial or natural. They are provided by, the aroma industry. So we buy this on the market.
Okay. You don't know if it's artificial or not, because consumers these days are looking for really natural alternatives. So.
Of course, but this is for experimental reasons. So we just use the aroma we can buy and which are very representative of the target we want to have. For example, Comté cheese or sardine or smoked salmon or whatever.
Okay, thank you.
Another question here.
Thank you very much. I had a question regarding the test you did in the cheese with the flavor of sardine. Was the taste of fish or the different aromas you put in the food, was it perceived or perceptible by the consumers as fish, or was it lower?
In this experiment, if you remember, we use 3 aromas, which is sardine aroma, Comté cheese aroma, and carrot aroma. Our first aim was to have an aroma which is a control aroma, which is carrot aroma, which is not associated to salt. And we use 2 salt-associated aroma, Comté cheese and sardine. One of these aroma, we expect it to be congruent with the product, which is the Comté cheese. And one was expected to be non-congruent with the product, which is the sardine aroma cheese, because sardine is not very associated to cheese, at least for French consumers. So the answer is yes, they can perceive the aroma within the product. This is a low intensity level, but we also ask for liking of this product in our laboratory, and there is not so much difference between the sardine product and the Comté cheese product. So this cannot explain the difference we see between these 2 aromas. But it was performed in laboratory conditions, so liking in laboratory conditions is not a forecast of what can happen in real life, I think.
So just so that I understand well, so they were able to, the level was high enough for them to recognize the sardine aroma?
Yes, the answer is yes. They clearly perceive this. Sardine is like smoked sardine, so they perceive this smoked fish odor into the product. But they did not seem to dislike it very much.
Okay, I think we have to go. Thank you very much again.